Hello, and welcome to the Frontiers of Science podcast, the show taking a look at the weird side of the edge of science. This week's episode was written by Marlene Wendl, an economics student here at the University of Groningen. And today, we're going to be exploring whether science can explain ghosts. And where does CERN come into this? I'm Henry Boeree, and without further ado, on with the show. So according to mythology from Western cultures, a ghost or spirit is a dead person who interacts with the living world. They can be described as like an invisible presence, translucent or barely visible wispy shapes to realistic lifelike forms. The general notion is that since energy doesn't stop existing but just transforms into other types of energy, also known as the first law of thermodynamics, some people believe that when people die, this energy is somehow transformed into a ghost, which can interact with the physical world. Now, if you believe that the human race is, quote, intelligent or, quote, enlightened, considering the fact there is no proof that ghosts exist, there is quite a lot of culture surrounding them. For example, in films and art, but also stories and myths and legends. But who actually believes in ghosts anyway? Well, maybe more than you think. According to a study, 18% of Americans say they have seen a ghost. And a survey conducted in Switzerland revealed that 20% of participants strongly agree that it is possible to make contact with ghosts. Now this tells us that around 1 in 5 of our listeners maybe believes in ghosts or maybe has seen a ghost. And if you've had some spooky experience that maybe science just can't explain, and you're at the Petrus Campus Festival today, well, we'd love you to share it with us. So centuries ago, when science couldn't explain spooky phenomena, a large majority of people were superstitious or believed in ghosts. Some scientists back in the day actually came up with some experiments in an attempt to disprove them. For example, Michael Faraday, a 19th century scientist, conducted an experiment around the supernatural phenomena of table moving, in which a group of people stand around the table with their hands placed on the surface. After a while, the table starts to move, which was then thought to be the ghost or spirit in that table. Faraday found, however, that in fact people were subconsciously moving the table themselves. After he made the subjects aware of this, well, the table didn't move. Another popular way of contacting ghosts, perhaps some of you have heard of this, is by using the Ouija board. And for those of you who haven't heard of the game, it's a board with letters, numbers, and the words yes and no. Players put their hands on a pointer and ask questions. Great Spirit, what is your name? How did you die? That sort of thing. The ghost can then reply by making the pointer move across the board, spelling out responses to the questions. When participants are blindfolded, however, the pointer wanders to places on the board where there are no letters, or wanders off the board completely. Physiologist William Carpenter in 1852 called this phenomena ideometer action, which is when participants execute involuntary and unconscious movements. And you might be thinking, well, okay, this was all centuries ago. What does modern science say about ghosts? And this brings us to CERN, the European Organization for Nuclear Research. At CERN, or the LHC, the Large Hadron Collider, 2 proton beams circle around the LHC and are sped up. Particles collide at nearly the speed of light, around 99.999999% the speed of light, so pretty fast. Scientists then analyze these collisions in order to find out how elementary particles interact and behave, and get closer to understanding our universe. This may sound a bit abstract, so we're going to go a bit deeper into particle physics to get a better idea of what is really going on. While we were at CERN, unfortunately only virtually, we learnt about the standard model of particle physics. It's a model that describes what our universe is made of. As of today, the universe is made of 12 particles of matter, 6 quarks making up protons and neutrons, and 6 leptons which make up things like electrons. The 4 forces that hold everything together as well. Now, those of us who remember some of their physics lessons in school might recognize a few things here. Protons and neutrons, for example, found inside the atomic nucleus, are made up of these smaller particles called quarks, and electrons go around the nucleus. So at the LHC, particles collide with each other at very high energies, either creating brand new particles like the Higgs boson, or scientists can learn more about the behavior of particles we already know exist. So what does particle physics have to do with ghosts? You may have heard of the rock star scientist Brian Cox, who actually works on one of the experiments at the LHC, and he shed some light on this. As mentioned, ghosts are considered to be made out of energy, since they can't be made of matter. They pass through things, for example, and matter doesn't allow this. Also, the second law of thermodynamics implies that if ghosts were made out of just energy, they would quickly dissipate, because energy is always lost to heat. Hence, the only way that ghosts would be able to exist for longer periods of time were if they had their own, an additional source of energy. And according to Mr. Cox, there is nothing in the standard model that accounts for this, nor has anything similar been observed at the particle accelerator. Thus, in order to explain ghosts, there would have to be an extension of the standard model of particle physics that has escape detection at the LHC, which Mr. Brian Cox deems to be almost inconceivable at the energy scales typical of particle interactions in our body. In short, if ghosts did exist, then the LHC would have detected them already. So is that it? Surely there must be more to it. Well, maybe there is. Cosmic Ghoul by John Updike. Neutrinos, they are very small. They have no charge and have no mass and do not interact at all. The Earth is just a silly ball to them through which they simply pass like dust maids down a draughty hall or photons through a sheet of glass. If we return back to the standard model, you will observe 3 particles, leptons, called neutrinos. They were first theorized in 1930 to explain a tiny loss of energy from other particle interactions, and were first detected in 1956. What are they? Well, neutrinos were first formed in the first second of the early universe, before even atoms could form. They are produced in the nuclear reaction of stars, like our sun, and nuclear reactions here on Earth. The particle gets its name from being electrically neutral, and because its rest mass is so small, it was long thought to be 0. And because neutrinos only interact with the weak subatomic force, they typically pass through normal matter unimpeded and undetected. This is why they are sometimes referred to as ghost-like particles. They can pass through the earth and your body as though they weren't even there. To illustrate this, if you hold up your hand and look at your thumbnail, which is about a square centimetre, there are approximately 60 billion neutrinos per second from the sun passing through your thumbnail. I don't know what you think. This sounds pretty ghostly to me. Here's the catch. They almost always pass through matter, but occasionally they hit something. And in 1998, scientists discovered that neutrinos do in fact have mass. The mass of the neutrino is much smaller than that of the other known elementary particles. 500,000 times less than an electron. And the mass of an electron is around 9 to the power of minus 31 kilograms, which is incomprehensibly small. To study neutrinos, scientists create what are called neutrino beams. CERN sent a neutrino beam to Italy, where it was observed, and study the particles, protons, neutrons, etc., that emerge when a neutrino hits a nucleus. As you might imagine, this requires a lot of patience. It took 3 years for the opera experiments in Italy to detect around 16,000 neutrinos, and this represents a handful per day. So neutrinos may sound very spooky and ghostly. They are not actual ghosts as we conceive them, because they have mass, and thus we can pretty safely say they don't exist. That's all we have time for today. Be sure to check out the other episodes of the Frontiers of Science podcast. On the next episode, we'll be asking if CERN is capable of creating black holes. And if it does, well, what do we do about that? I'm Henry Boeree, and as always, thanks for listening.